Hi guys, today we are focusing on the standard 2-2, which talks about processes on the Earth that have changed Earth's surface at different time and spatial scales. So we'll talk about what this means through a learning target. So we're on LT2. We're going to be talking about something called plate tectonics. We're going to talk about forces that cause plates to move. We'll talk about what they are. We'll also talk about plate boundaries, and we're going to talk about earthquakes, tsunamis, mountains, and volcano formation, what they have to do with plate boundaries. So let's get started. Alright, so first thing we need to kind of clarify before we understand how plate tectonics works is that we need to know there's two kinds of crust. So last time we met, we talked about the different layers of the Earth, and you guys know the outer layer is the crust. There's actually two types of crust. We have continental crust, which makes up the continents, and it's made out of a lighter granite rock. And then we have the oceanic crust, which makes up the crust of the ocean, and it's actually made out of basalt rock, which is a type of rock that's denser than granite. So this is going to be important to know because when these different crusts interact with each other, the denser ones tend to go on the bottom and the lighter ones tend to go on the top. And we'll talk about how that happens in the next few slides. Alright, so now let's talk about this word called tectonic plates, or words, tectonic plates. So tectonic plates are pieces of the crust that move on top of the mantle. If you guys remember, the mantle is the second layer under the crust. And there are approximately 12 main tectonic plates and a few smaller tectonic plates in addition to the 12. But here's a picture of the tectonic plates, and this is kind of a weird picture, so I just want to clarify. We have the continents here. Here's North America, South America, Africa, there's Australia and Asia and Europe, and you can see that the tectonic plate lines are actually, some of them are in the ocean, some of them are right in between the ocean and the continents, but this is basically where the crust is divided. And these plates actually move around. So let's talk about how they move around or why. So last time we met, we talked about the different layers of the Earth. Here's the crust, mantle, outer core, inner core. And the plates are part of the crust, which is the outer layer of the Earth. Now, these plates move because of the idea of convection. And last time we did a little demonstration that kind of explains what convection is. And it's the circular movement of heat. And it happens because as there's heat from the core heating up the mantle, the hotter rocks will tend to move up because they're less dense, and then as they're up here, they cool down, and cooler things tend to sink down because they're more dense. So that causes the cooler rocks to move down, and then it gets heated up again, and then the cycle continues. So remember, that's convection. So we have this really slow circular movement in the mantle, and what happens is that the crust is kind of floating on top of the mantle, which is half melted. And when things in the mantle are moving around in a circle, it causes these plates, or part of the crust, to kind of move around. And that is how the plates move around. And we're going to talk about how these plates kind of interact with each other as convection occurs in the mantle in the next few slides. Alright, so how do the plates move? So a good analogy to kind of understand how plates move is ice cubes and water. So the ice cubes can represent the plates, and the water can represent the molten mantle. And just like how ice cubes kind of float in the water and kind of move around kind of randomly, imagine there's multiple ice cubes and they kind of bump into each other. That is how the tectonic plates also kind of move on the mantle, and so they're floating on top of the mantle. And of course, there's no like huge gap like this in the Earth, but they kind of crash into each other, just like how ice cubes would. So now let's talk about plate boundaries. So a boundary is where two plates meet. So this arrow kind of is pointing to one boundary between the Australian plate right here and this other plate right here. And everywhere where you see a black line, that is a plate boundary. Now, there's 3 different kinds of plate boundaries, and we categorize them based on how they move. So we have convergent, divergent, and transform boundaries. Let's go ahead and kind of explore each of these 3 boundaries. And you can actually kind of see how boundaries are different from this picture. I don't know if you guys can see it. Let me zoom in really quickly. Oops, wrong way. You guys can see that these arrows kind of represent the movement of the plates, and basically these movements are either transformed, convergent, or divergent. So let's talk about the different types right now. Alright, so zooming back out. Oops. Okay, so here we go. So let's look at convergent plate boundaries. So convergent plate boundaries are basically when 2 plates are colliding into each other. So here is one plate, and here's another plate, and they are riding into each other. You can see there. And actually, this one here is going under this one because this one is more dense. It's made out of rock that's heavier and has more atoms and molecules than this one, so it goes under. And a really good example of a convergent boundary is the Himalayan mountain range. So the Himalayas are located in between India and China. It's also part of Nepal, which is located right in between these 2 countries. And we have a plate that's pushing this way, and then another plate that's pushing this way, and that is causing the Himalayas to form. And one of the most famous mountains that's part of the Himalayas is Mount Everest, which is, here's a picture of Mount Everest, and it is the tallest mountain on Earth. This was formed because of 2 convergent plate boundaries. Now let's talk about divergent plate boundaries. So divergent, the word divergent means to pull apart. Convergent means to come together. So you can, maybe an easy way to remember it is divergent is like divide and convergent is like coming together. So they both, so anyway, divergent plate boundaries, as you can tell from this picture, is when 2 plates are moving away from each other. And when this happens, the magma underneath in the Earth's mantle kind of ooze out, and they tend to form new crust. And so in this picture, here is a map of the Earth, but it shows where the divergent boundaries are. So wherever there's a red line here, this is actually where there's divergent boundaries and new crust is being formed. And the red shows the newest crust of the Earth, and as you move towards away from the red, this is where the older crust is. And so right here, where you in the Atlantic Ocean, this is North America and this is Europe. The Atlantic Ocean actually is a very famous divergent boundary called the Mid-Atlantic Ridge, and this is actually where the newest crust is forming, and actually the Atlantic Ocean is growing bit by bit every year because it's actually moving away, or pushing, the divergent boundaries are pushing the continents away from each other and making the ocean bigger. Alright, now let's talk about transform plate boundaries. So transform plate boundaries, as you can see in this diagram, is when 2 plates are sliding past one another. So in this picture, this plate is moving this way and this plate is moving this way. One of the most famous transform plate boundaries is right here where we are in California, and that is the San Andreas Fault line. And we have the Pacific plate on this side, it's moving in this direction, and we have the North American plate on this line, and it's moving in this direction. And this is the cause for many earthquakes, and we're going to go into that more detail in a few minutes. Alright, so now let's talk about why should we even care about these tectonic plates? How does it affect us? Well, tectonic plates changes Earth in many, many ways. So it causes mountains to form, as you can see in this picture right here. It can cause volcanoes to form. It causes earthquakes to form, as well as tsunamis. So, and of course, those major natural disasters can affect many people at once. And actually, it's something that we really can't control. It's something that is happening because of the things that the Earth is doing under the Earth's surface. So let's talk about each one in more detail. Okay, before we do that, let's talk about this really, really famous area called the Ring of Fire. So the Ring of Fire is this area in the Pacific Ocean, and you can see it's marked here. I know it's kind of hard to see. Let me see if I can zoom in for you guys. So the Ring of Fire is this area that is in the Pacific Ocean, and basically it is an area where there are a ton of convergent boundaries. And basically, because there are convergent boundaries, so one plate is pushing in this way and the other plate is pushing in this way, and they're kind of smacking into each other, this area is an area where there are many volcanoes, trenches, and earthquakes. And something like 90% of all earthquakes and 75% of all volcanoes are found in this area called the Ring of Fire, because if you look at this map, here's the Pacific plate. You can see the Pacific plate is crashing into all these other plates. And that is, and they're convergent, so you can see the arrows are pushing against each other here. See, this is where there's a lot of convergence, and that's why we have a lot of these natural disasters along the Ring of Fire. Alright, so now let's get into how mountains form. So, when two plates of continental crust collide at a convergent boundary, which is when two plates are crashing into each other, sometimes the crust will fold and buckle and it forms a mountain. So that's how mountains will form. Now let's talk about volcanoes. So how do volcanoes form? Well, again, there's a convergent boundary, except in this picture we have the oceanic crust crashing into the continental crust. And the oceanic crust, as I mentioned in the very beginning of the video, is more dense than continental, so the oceanic crust is going to go under the continental crust. We call this subduction. Here's the arrows pointing to that. And what happens is, as the oceanic crust is pushing down into the continental crust, it causes a lot more pressure in this area. And what happens is the surrounding rocks in this area will start to melt and form more pressure. And that pressure is going to push that magma out, and it's going to form a volcano. And this doesn't have to happen in the ocean. It could also happen on land, which is why we also have land volcanoes. Now let's talk about how earthquakes form. So earthquakes form also at plate boundaries. When two plates are sliding past one another, it causes a lot of pressure, and sometimes that pressure causes cracks in the earth, and we call those cracks faults. So here's an example. We have in California the Pacific plate moving in this direction and the North American plate moving in this direction. This is a transform boundary, and the pressure here that's built along the plate boundary causes a lot of cracks, and one of the most famous cracks is called the San Andreas Fault, and here's a picture of the San Andreas here. The San Andreas Fault is one of the biggest cracks, but it also, this movement causes a lot of smaller cracks in and around Los Angeles. So this is a map that shows all the different faults around Los Angeles. This is the San Andreas right here. You can see it's one of the bigger cracks, but all these little green lines, they're faults. They're cracks in the earth caused by the stress from the movement of these plates. Whenever there is a slip in any of these rocks, these fault lines, whenever these rocks slip past one another, that's what causes an earthquake. And that movement will trigger the earthquake to move along those fault lines. Last but not least, let's talk about how tsunamis form. So tsunamis form at convergent boundaries. Usually it's an oceanic plate that's subducting under the continental plate, again, because it's more dense. And what happens is, instead of it falling down, instead of the oceanic plate kind of riding down smoothly, a part of it gets stuck. And as more and more pressure builds in this stuck area, at some point it's going to snap and it's going to buckle. And when it does, what happens is, one, it releases an earthquake here, and two, the water above it is also going to form this gigantic wave, and that's when it causes a tsunami, a humongous wave. Now, one famous tsunami that you guys may know about, it was the tsunami in Japan, and one of the reasons why it was located there was, if you look at where the plates are in and around the island of Japan here, it's really look at, there's 4 plates and they're all converging. So it's really prone to having more earthquakes as well as tsunamis.